So in the previous lecture, we have discussed about the suppose if we start from the methane gas, which is found in the coal mines and marshes places. So if you replace one of the hydrogen atom of methane by carbon and join the required number of hydrogens to satisfy the tetravalent of the other carbon atom, what do you get? You get the C2H6, right? Then the same way, if you again replace one of the uh, one of the hydrogen, one of the hydrogen with another carbon chain with required hydrogen valence with required number of hydrogen to satisfy the tetravalence of the other carbon atom, then what you will get? You will get the C3H8. Now, if it is the starting material, let's say you start from C3H8, and now if you replace one of the proton or hydrogen with another carbon with required number of hydrogen to satisfy the tetravalence of the other carbon atom, what do you get? So you get the C4H10. So you get C4H10. Now, so you get this compound C4, which is known as the C4 and H10. Okay. Now the question is, so let's say we are now here C4H10. Now the hydrocarbons are inert under normal condition as they do not actually react with the acids, bases, and the other reagents. Okay, hence they were earlier known as the paraffins. Why? Because the hydrocarbons are the what does it mean actually? So the paraffins mean in the Latin words. So it's coming from the Latin words. So Latin word means the parum, and the little means the affinis or affinity. That means the little affinity towards any kind of reactivity. That's why the hydrocarbons are the inert under normal conditions. Okay. Can you think of the general formula of alkane family or homogeneous series? Now I'll come to the now this is come to the picture. Then what can be the general formula for the alkane family? I already this is already I have spell out in the previous lecture, but still I will just go quickly 5 minutes for these things. So let's say then it will be easier to remember or recall the previous things. So that's why we started. Let's say we started from here. So can you think about the general formula or alkane family or homologous series? So that is the CnH2n plus 2. That is C2H6. Now let's say C2H6. You have C2H6. Now again, so let's say you start from the CH4. CH4 is not the CnH2n plus 2. Let's say carbon is 1. Now let's say this is the CnH2n plus 2. So now if you see the CnH2n plus 2, that means Cn, if n equals to 1, then what you will get? C1 and H2n plus 2. So 2 into n means 2 into 1 plus 2. That means total 4. So what you are getting? That is equals to CH4. So 1 carbon contain the CH4. When you will go to the 2 carbon, what you will get? So let's say C2, that means n equals to 2. Let's say n equals to 2. Now hydrogen is the 2 into 2, that is 4 plus 2. That means what? 6. So C2H6. Now let's say we go from the C2H6 to C2H6 to C3H8. Now let's say C3H8, how it will come? Let's say Cn, n equals to 3 and hydrogen equals to 1. So 3 into 2, that is 6 plus 2. That means C3H8. Okay. Now not only C3H8. Now can I go to the higher carbon chain, that is C4, when n equals to 4. So let's say n equals to 4. Now 4 into 2, that is 8. And then what you will get? 4 plus 2, 8 plus 2, that is 10. So if your carbon chain is, if your number of carbon is 4, then hydrogen should be 10. Then only it will satisfy the one of the general formula for the alkane family. So this is also belongs to the alkane family. Okay, C4H10. C4H10. Now you'll go to the today's lecture. That is the today's lecture is the based on the if we examine the different alkanes, we found that the formula, general formula for alkane is general formula for the alkane is CnH2n plus 2. Okay, already I discussed the CnH2n plus 2. So this is the you have to remember these things maybe in your competitive exam or any IIT JEE exams. Maybe people can ask this kind of question. So what is the general formula for the alkanes? Okay. Now it represents any particular homologa when n is given appropriate value. So can you recall the structure of methane? According to Vesper theory, VSEPR theory, unit equals to 4. So now the methane has a tetrahedral structure. Okay. Now in which carbon atom lies at the carbon atom is in the center. Now and the 4 hydrogen atom lie at the 4 corner of a regular tetrahedron. All carbon hydrogen bond angles are of 109.28. Okay. So 109.2 from where it is coming? HCH. HCH bond angle is the HCH. This bond angle is 109.28 minute. Okay, so 109.28. Okay, now this is a regular tetrahedron moiety. So the structure, I will also show you the picture how the methane looks like, but it is like this way, pure tetrahedron, regular tetrahedron structure of a methane molecule. Okay, now if you go to the alkane tetrahedra are joined together in which in alkanes tetrahedra are joined together in which carbon carbon and carbon hydrogen bond lengths are carbon carbon bond length, where the carbon carbon bond length in alkanes tetrahedra are joined together in which the carbon carbon bond length is the 154. So then you have to remember that the bond length of the carbon carbon bond length if anywhere it will ask that in bond angle a bond length of the CC single bond, then it will be 154 picometer 154 154 picometer. Now the bond length of the CH bond. So now let's say CH bond length equals to 112 picometer respectively. 112 picometer respectively. Okay, so this is the bond length. So we have to also remember these things that you have already read that the carbon carbon and carbon hydrogen sigma bonds are formed by head-on overlapping. You can see that if you see the structure, the sp3 hybrid orbital of the carbon and 1s orbital of the hydrogen atom. So now let's say we start from if you see the structure of this one. So I have taken this picture from your book only. So if you see this one, so this is the let's say CH4 molecule, where the molecular orbital MO also given here, how the bond is forming. So they are using, so this bond, this is the coming from sp3. This is actually sp3 orbital. sp3 orbital, and this is the pure s orbital. This is the pure 1s orbital. Pure 1s orbital. This is the pure 1s orbital. Okay. Now this is the pure 1s orbital, and this is the sp3 orbital. So now the sp3 hybrid orbitals of carbon, sp3 hybrid orbital of carbon, sp3 hybrid orbital of carbon and 1s orbital of hydrogen atom, is forming the overlapping. Then only, and it is also a head-on overlapping. Okay. This is also we have to remember that this is a head-on overlapping. And which kind of bond? Maybe people will ask. You can remember the carbon is using sp3 hybrid orbital and one hydrogen is using the 1s orbital. Okay. Now we'll go to the nomenclature part. Okay. So what is nomenclature? Okay. First, we have to know that what is nomenclature and isomerism. So actually, nomenclature means suppose one you have two organic molecules. So how to how to call them means how to pronounce them. This is the difference from this one. So then we have to give a particular name to that molecule, right? So in which basis we will give this name? So these are all rules we have to go through. So I'll discuss one or two examples. Then we'll discuss why it is so, why it is calling as a this in this name. So then I will discuss. So let's say we start from the butane. Okay, butane. Means what? N equals to means carbon will be 4. I told you. So when carbon is 1, that is meth. Carbon is 2, that is eth, and the carbon is 3, that is when the C3, that is prop, that is C4, that means butte. So here it is given as a prop, right? A butte. So butte means so meth. If you start from the methane, methane, methane means C1. Okay, ethane means C2. Ethane means how many carbon? Eth means C2. How many carbon is present? C2. Now let's say prop. Prop means C3. Now butte. Let's say butte. Butte means C4. And pent. Pent means C5. Okay. So the thing is that butane, N-butane and 2-methyl propane. Okay. N-butane and 2-methyl propane. N-butane is the C4, that is CH3, CH2, CH2, CH3. Boiling point is 273 Kelvin. Okay. And this is the 2-methyl propane, isobutane. Okay, isobutane is the 2-methyl propane. Why it is calling as isopropyl? Because you can see one CH proton is there. So in the previous my chapter, I already discussed what is iso and what is neo. Here also we'll discuss. So let's say first we'll see how many carbon is present. 1, 2, 3. So we are now only in the alkane moiety, not alkene. So whatever you will get, this is the propane, right? So 3 carbon, 3 mean prop and N. Why? Because it is a because it is coming from because it is a alkane. So that's why propane. Propane is already coming. Now we have to see in which carbon any other substitution except hydrogen, any other substitution already added or not, or already present or not. So if you see the C2 position, so there is a one CH3 molecule is there. So CH3 we know that this is a methyl. This is called methyl. And which carbon? 2 carbon. Number of carbon 2. So that's why the propane. First we'll write the propane, and then we have to write the 2-methyl propane. And this is also known as a isobutane. Why? Why butane? Because you can see if you count in this way. So 1, 2, 3, 4. Okay, 1, 2, 3, 4, and CH is here. Okay, so that's why you can call as a or 1, 1, 2, 3, 4. Isobutane. You can also call it as isobutane. If you any here see in the middle carbon or anywhere CH is there and alkane moiety and there is some other group is present. Only CH single CH is there. Then you can say the iso. Okay. Now coming to the third example, that is the first we will see the how many carbon present here. So you can see 1, 2, 3, 4, 5. So total 5 carbon is there, and no other than hydrogen, no anything else is there. No other substitution is present here. So that means you can say that is a pentane, that is N-pentane, right? And what is the boiling point of this pentane? That is the 309 Kelvin. Now coming to the structure number 4. What is the structure number 4 is the you can see the count of number of carbon present in this molecule is the 1, 2, 3, 4. So total 4 carbon present here. Now if you see the 2-methyl butane, okay, so 2-methyl butane is the isopentane. Boiling point is the 301 Kelvin. Okay, so you can see the CH3, CH, CH3, CH2, and CH3. So this is a 2-methyl butane, and the boiling point is the 301 Kelvin. So this is the in the previous structure also we have seen that this whenever you see any CH proton, so that means you can say it is a iso. And iso, how many carbon is present? Means considering including the CH3, it will be pent, means 5 carbon. That is isopentane. The boiling point is the 301 Kelvin. Now the 2,2 dimethyl propane. So neopentane. So that is neopentane. Okay, neopentane when you see any quaternary carbon, if you see any quaternary carbon, any CH proton is there, then it is called as a iso. And when you see 4 different group is present, let's say R1, R2, R3, and this is a R4. So that means so that means it is a quaternary, and this is a iso. So that it is a iso, but this carbon has a this is carbon, this is carbon, this is carbon, this is carbon. So that is why it is a total number of carbon 1, 2, 3, and 4, 5. So total is the 5 carbon is present here. So that's why it is known as the neopentane. Now coming to the actual now IUPAC name. So 1, 2, 3, and the 2 carbon 2 methyl is there. So 2, 2 dimethyl, because 2 methyl is present. That's why dimethyl. And propane, because total number of carbon is 3 only. So that's why it is coming first propane, then 2, 2 dimethyl. This is a methyl. One methyl is coming from here, and the other methyl also coming by here. So that means it is a 2, 2 dimethyl propane. It is also known as the neopentane. Okay, and the boiling point is in the case of neopentane 309, and the 2 methyl isobutane, that is the 301, and the boiling point is a 282.15. So what it reflects actually. So when we go from the normal to branch, that means normal to branch means the boiling point will decrease. So when you go from branch to normal means the chain to branch, chain to branch, that means boiling point will decrease. Boiling point will decrease. You can see the N pentane is 309. When you are just one branch come here, that is boiling point decrease 8 degree, 301 Kelvin. The moment it will come to the another branch, it will come to the 282. From the 309 to 82 means 18 plus 9. That means 27 degree difference. So that means when the branch is more, so that means the boiling point will be less. Okay, so this is the physical difference. So that is why we should difference between the, so obviously the physical properties, chemical properties also difference from the isomerism. These are all isomerism. From N pentane to isopentane to neopentane. So these are all the isomerism, isomer of the N pentane molecule. Okay, just how to represent in different way. N pentane, the molecular formula is same, but only how to represent. If you see the molecular formula will be how much? So let's say C5H12. Everywhere you can see that H12 will be present. So in 3 structure C5 is there, but if you count the hydrogen atom, so one is in one carbon, that is a 3 to 5 to 7 to 9 and 3 to 12. Here you can also count. So total carbon is 5. So 3, 6, 7 to 9, 3, 12. Here also you can count. The total 5 carbon is present. Okay, and the number of proton is the 3, 3, 3, 3. So 4 into 3, that means 12. The total carbon hydrogen is also 12. So 12 hydrogen is also present here. Now, now we have to go to the next part. So you can see, so what they are saying, structure 1 and 2. Structure 1 and 2 is the same molecular formula but differ in their boiling point and the other properties. Similarly, structure 3 and structure 4 and structure 5 was the same molecular formula but have the different properties. Structure 1 and 2 are isomer of the butane, but the structure 3, 4, 5 are the isomer of the pentane. Since difference in properties due to the difference in their structure, they are also known as the structural isomer. This is also known as the structural isomer. So people can ask, they what are the structural isomer of the N-pentane? Then you have to say the N-pentane structural isomer is the N-pentane structural isomer. N-pentane structural isomer is the isopentane, isobutane, sorry, isobutane or isopentane, sorry, isopentane, iso, isopentane, isopentane, and neopentane. Isopentane and neopentane. Okay, it is clear that the structures of 1 and 3 have continuous chain of carbon atom, but structures 2, 4, and 5 have a branched chain. But structures 2, 4, and 5 have a branched chain. Such structural isomers which differ in chain of carbon atom are known as the chain isomers. Thus, you have seen that C4H10 and C5H12 have 2 and 3 chain isomers respectively. Okay, C4H10 is the N-butane. Okay, N-butane, N-butane. So N-butane have only 2 structural isomers. What are the structural isomers? One is the N-butane and the isobutane. So one is the 2 possible structural isomers possible. One is the N-butane, and second one is the isobutane. N-butane. The second one is the isobutane. But in the case of N-pentane, there are 3 possible structural isomers are there. So one is the N-pentane, second one is the isopentane, third one is the neopentane. Okay, now I'll coming to the one question answer section. Now, so whatever we discuss here, so based on this, can we go for some question answer session? IUPAC name. So if you see the IUPAC name, so if you see the IUPAC name of this one solution, CH3, CH2, CH2, and CH2, CH2, CH3. This is called the N-hexane. Okay, this is called N-hexane. So this is called, so different molecular right structures of different chain isomers of alkanes corresponding to the molecular formula C6H14. Also write their IUPAC names. So CH3, CH2, 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 CH3. This is the N-hexane. And CH3, CH3, CH2, CH2, CH3. So 2-methyl N-pentane. So then we can recall as a CH3, CH2, CH3, CH2, and CH3. So this is actually known as the solution of the different chain isomers of the alkane C6, and corresponding to that, we know that the N-butane. If you see the N-butane, only 2 structure possible. Right. In N-pentane, that is a 3 structural possible. And in case of C6, there is a 4 structure possible. So N-hexane first. Then coming to the 2-methyl pentane, 1 branch in the C2 position. Then it can also possible the C3 position. Then the this is the also 2,3 dimethyl butane. Then it is the 2,2 dimethyl butane. So how it is working? So let's say you have a CH3 and CH3. Let's say you have a CH3, you have a CH3. Now you go to the total number of carbon atoms, 6. So CH3, CH2, CH2, CH3, CH2, CH2, and CH2. CH3, CH2, CH2, CH2. So 3 and 3, CH2, CH2, and CH2, and 4, and now it is a CH3. Okay. Now this is the N hexane. Let's say N hexane. Then we just replace one of the CH into CH3. So one of the CH3 it will come. Then what we'll get? The CH3 and CH2. Then CH2 CH3. So this is called 2-methyl pentane. Okay. Now the third one. Third one is the CH3, CH2, CH, CH3, CH2, CH2, CH3. So this is known as the 3-methyl pentane. The fourth one is the CH3, CH, CH3, CH, CH3, and this is also on CH3. So that means 2, 3 dimethyl di 2, 3 dimethyl butane. Okay, cool. The 5 one is the CH3, C, CH3, and then another CH3 will come here. It's like a new group, quaternary carbon. So you can see here also iso. This is also iso. This is also iso. But here it is a neo. Okay. So this is called 2,3 dimethyl butane. 2, 2 dimethyl butane. 2, 2 dimethyl butane. Okay. Now let's say if we start from here. Now, based on the number of carbon atom attached to a carbon atom, the carbon atom is termed as primary, secondary, tertiary, or quaternary, and carbon atom attached to no other carbon atom, as in methane, or to only one carbon atom, as in ethane, is called as a primary carbon atom. So, terminal carbon atoms are always primary, and the carbon atom attached to two carbon atoms is known as secondary. Tertiary carbon is attached to three carbon atoms, and neo or quaternary carbon is attached to four carbon atoms. Okay. Can you identify 1 degree, 2 degree, 3 degree, and 4 degree carbon atoms in? So terminal termed as a primary. Primary is in general 1 degree. Secondary is 2 degree. Tertiary is 3 degree. Or quaternary is 4 degree. Now carbon atom attached to no other carbon atom is known as the methane, or to only one carbon as is known as the ethane. It's called the primary carbon atom. Terminal carbon atoms are always primary carbon atom attached to two carbon atom is known as the secondary. Tertiary carbon is attached to three carbon atom, and neo is attached to the four carbon atom. Can I identify that now this one? Now this is the okay. So before going to this part, here I can see like CH3. CH3 also primary. This is also primary carbon. CH3, CH3. Sorry, this is CH4 methane. CH3 and CH3. That is known as the secondary. Not secondary. Sorry, this is also primary. Ethane. Now, if you see the secondary, ethane. Now, let's say CH3, CH, CH3, CH3. Now, let's say this carbon where the CH only present. This is called as a secondary. And this one, this one, all are primary. These are all primary carbon atom. Only the middle carbon where the CH only present one hydrogen. This is called secondary. And the tertiary carbon is attached to the three carbon atom. Tertiary carbon atom. And the second terminal carbon atom over primary carbon attached to carbon atom is known as the secondary. Tertiary carbon atom is attached to three carbon atom, and neo-quaternary is total four. Like this one, this one, this one. So this middle carbon is attached to the four carbon. So that's why it is called a quaternary. Quaternary. Okay. This is how we have identified the primary is the 1 degree, secondary is the 2 degree, and the third degree is the and the third degree is the tertiary. Okay, and the fourth degree is the quaternary. Now, if you see the right structures of different isomeric alkyl groups corresponding to the molecular formula C5H11, right? IUPAC names of the alcohols obtained by attachment of the OH group at different carbon atom chain. So they are asking right structure of different isomeric alkyl groups corresponding to the molecular formula C5H11. Right, IUPAC names of alcohols obtained by attachment of OH groups at different carbons of the chain. Now, structure of C5H11 structure solution. Now let's say the C5, CH3, CH2, 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 CH2. Now let's say corresponding alcohol. If you want to see the corresponding alcohol part is like it. So let's say we have how many carbon? One, 2, 3, 4, 5. So 1, 2, 3, 4, 5. 5 carbon and one OH. So that means OH is present this carbon. So 1, 2, 3, 4, and it is 5. Now it is pentane and 1 all. Now it will be how? So first you write the how many carbon is present here? 5. So that means pentane. Now in one position OH is present. So 1 all. And this is you start from here. Now if you start from here, so you can see now if you start from here, so you can also start from here or here, but if you start from here, so let's say 1, 2, 3, 4, and this is 5, but 4 carbon OH is present. But if you start from here, 1, 2, 3, 4, 5, here 2 carbon present in the number of carbon in the 2 carbon which is present. So this will be more preferred. Why? Or the less we always need the not the less number of carbon always we need, not the higher carbon we need. Only the less carbon atom containing the functional we start from that side only. So now it's a 1, 2. So that means so how many carbon is present? Pent. Now 2 position 1 OH is present. Now pent 2 1. Now here. So let's say 1, 2, 3, 4, 5. You can also start from here 1, 2, 3, 4, and 5. Wherever you go, you'll end up in getting 3 carbon here only. So pent. Now let's say you start from here. We see here how it is looks like. So 3 methyl and the CH2OH. Now let's say 1, 2, 3, and it is a 4 carbon, right? Then that means 3, 4, and then the 1 is all. So butane 1 all. Butane 1 all. but methyl is present in the 3 carbons. So that means we have to write 3 methyl. 3 methyl. Now here, let's say we start from here. 1, 2, 3, and 4. So that means butane 1 all. Butane 1 all. Now let's say 1 and 2 position methyl is present. That means 2 methyl. Butane 1 all. Okay. Now let's say 1. So 1, 2, 3, 4. Now we start from here. So butane 1 all, and then 2 methyl butane 2 methyl butane. This is a 2. Now here we start from 1, 2, 3. So that means this is propan and 1 all and 2 dimethyl. So how will write 2, 2 dimethyl? Now you can write here because 2 methyl present in 2 positions. So 1, 2, and it is 3. So that means propan 1 all and 2, 2 dimethyl. 2, 2 dimethyl propan 1 all. Okay. Now let's say 2, 2 dimethyl propan 1 all. Now we'll go to here. Let's say CH3 and CH3 CH2. So let's say we'll start from here. 1, 2, 3, 4. So how many carbon is present here? Butane. So let's say but, and now 2 carbon oxygen OH is present. So butane 2 all. And now in the 3 carbon CH3 present. So 3 methyl. Okay. Now we'll go to the some other example. Okay. Other example is this one. The structure and IUPAC. So let's say this is a pipe structure is given here. CH3, CH2, CH2. Let's say we'll write here. Actually write here. You can also write, right? You can also write. So CH3, pH, CH3, then CH2, then CH, then CH2, then CH3, then CH2, H3. So that is 1, 2, 3, 4, 5. That is 4 ethyl, 2 methyl hexane. So that is 4 ethyl, 2 methyl hexane, right? 4 methyl, 2 ethyl hexane. So okay. I'll also speak it. Sure. It is as a 4 ethyl, 2 methyl. So you can see in the position of 4, because why we give the more priority compared to methyl to ethyl? Because ethyl is a higher priority compared to methyl. So that's why we given the 4 methyl and 2 methyl. Why? We can also start from here, right? But if we start from here, then it will be 3 carbon. But if we start from here, that will be 2 carbon. 2 carbon it branched. So that's why we started by here, so that we can end up in getting the exact or the perfect nomenclature of this molecule. So 4 ethyl and it is a 2 methyl and hexane. Now I'm coming to the second structure. So what is the second structure? That is a CH3, CH2, CH3, CH2, and this is also CH2. Then there is CH, then CH, CH3, and this is CH. Then it is CH3, CH3, then CH3, then C, it is a CH2, CH3, CH2, CH3, it is also CH2, CH3, and then it is also CH2, CH3. So now if you see here, let's start from here. Let's say 1, 2, it is 3, now it is 4, then it is 5, then it is 6, then it is 7, then it is 8. Okay, now if you see 1, 2, 3, 4, 5, 6, so lowest sum and alphabetical arrangement. So remarks is the lowest sum and alphabetical arrangement. So how we'll start? So let's say first is the octane, because 8 carbon is there. So that means first we'll write the octane. Now we'll go one by one. Octane. Now we'll go to the 4 carbon. 4 carbon, 1 methyl is present. Okay. Now 4 methyl. 4 methyl. Now you can see 3, 3 diethyl present. One is diethyl is here and the diethyl is here. So hyphen. Then I will go to the first part. So it is starting from there, and 5, 1 isopropyl, because this is isopropyl group. So 5 isopropyl, 5 isopropyl, isopropyl, and then 3, 3 diethyl, 3, 3 diethyl, 3, 3 diethyl, 5 isopropyl, 4 methyl, and octane. Okay, so secondary is not considered, and while arranging alphabetically, isopropyl is taken as one word. Okay, now coming to the third example. Now if we consider the third example is CH3, CH2, sorry, CH3, CH2, and then CH, then it is CH3 whole 2, CH3 whole 2, then it is a CH, then it is a CH, it is also CH3, then we have a CH2, CH3. Okay, now we go to the CH, then CH2, then again CH2, then CH2. Now we start the numbering 1, 2, 3, this is 4, this is 5, this is 6, this is 7, this is 8, and in between another carbon will be there, CH2, then it is 9, then it is this is 10. Now if you see in the 4 carbon, 1 isopropyl group is present. Okay, and 5 carbon, 1 secondary butyl. This is called secondary butyl. This is isopropyl, and this is 4 is the isopropyl, and 5 secondary butyl, and then is the 2 decane, because 10 carbon means is the decane. This is also called as a decane, DADECANE, decane. Now 4 isopropyl, right? 4 isopropyl, 4 isopropyl. Then we have a 5 secondary butyl, 5 secondary butyl, 4 isopropyl, decane. Sorry, 5 secondary butyl, 4 isopropyl, decane. So this is the main structure of the third molecule of the 5 secondary butyl. So this is called the secondary butyl. Why secondary butyl? This is the secondary carbon, and you can see 1, 2, 3, 4 butyl and 5 secondary butyl. This is a butyl group. This is also a secondary. So that's why it is called as a 5 secondary butyl. 5 secondary butyl and decane. 4 isopropyl decane. Now we will go to the next example is the D. Next example is the D. Let me erase some of the part so that we get some space and we can write it. Okay. So now whatever we are learning here, this is just a earlier step. So if we go to the complex molecule, then only we can understand the what is the importance of the nomenclature of the molecule. So maybe if you practice it more and more, then it will be helpful to you find the any complex molecule nomenclature. Okay, so it will help you, but you have to practice it more and more. Then only it is possible to go doing well here. So now let's say how many carbon here present? 9 carbon. So let's say 1, 2, 3, 4, 5, 6, 7, 8, 9. So total 9 carbon. And in the 5 carbon, 1, 2, 3, 4, 5 carbon, 1 CH2, and then 1 C, neopentyl group present here. CH3, and this is the CH3. This is CH3, CH3, and this is also CH3. Now you count the carbon atom. This is the non-N. Why non-N? 9 carbon is there. So that's why it is a non-N. Okay. Non-N. And now 5 carbon is present here. 5. Then it will go 2, 2. Why 2, 2? You can see. So if you count 1, 2, 3. 1, 2, 3. So 2 is the, let's say 1, 2 and 3. So 2, 2 dimethyl. 2, 2 dimethyl. Because 5 carbon, 1 CH is there. And any other carbon only CH2 and terminal is the CH3. So that's why it is known as the 5 dimethyl, 2, 2 dimethyl, dimethyl propyl, because 3 carbon is present. So that's why it is a propyl. From now, if you ask me from where this propyl group is coming, so 1, 2, 3, because 3 carbon present here, so that's why they are calling as a propyl. So 2, 2 dimethyl propyl nomen. Okay, now the one example left. Maybe next chapter, next class we'll discuss these things. Okay, so today is already, although the time is over, but today we discuss more. Because why? Because so many examples we have, question answer we have solved today. Okay, it's better not go far and not go means many questions today or one day, one lecture, because it will be much more confusion. Still, the next class also I'll start from here only. I'll just go quickly, briefly from this one, then so that it will be easy to remember. Not like it will not remember, easy to understand. Okay, thank you.